long good day in algebra will be coming PO4, power objective number 4. I can multiply and divide integers and fractions. And here's the nice thing that's going to become a common theme as we move through algebra. You'll actually start to like multiplying and dividing things more than adding and subtracting things. Just trust me on that. The reason why, like we saw in PO3, all those rules for adding and subtracting, especially fractions, right? Common denominators, they stay the same. All these things you've got to remember. As you'll see when we get down to multiplying and dividing fractions, all those are out the window. That's glorious. There are less rules, less things you need to remember when multiplying and dividing fractions than you do with adding and subtracting them. And that's actually a common theme that we'll get to with combining like terms and radicals and a lot of other things coming up in algebra. But first, we are going to start with integers. And when it comes to multiplying and dividing integers, the times tables that you memorized, hopefully, in like 3rd grade, 4th grade, 5th grade, all those stays the same, right? 8 times 3 is still 24, but because it's 8 times negative 3, how does that negative sign affect the product, Lucas? It makes it negative. 8 times negative 3 is negative 24. So with integers, you're really looking for what are my signs? And how do the signs of the numbers affect my product or my quotient? So a positive multiplied or divided by another positive number will be a positive. Yes, positive. A positive multiplied or divided by a negative will be a negative. And because of the commutative property, which says you can multiply things in any order, 8 times negative 3, which is negative 24, is the same thing as negative 3 times 8, right? You can reverse the order and still multiply and still be good. So if that negative were to come first, followed by the positive, you're still going to get a negative. And then a negative multiplied or divided by a negative, like we saw with adding and subtracting, those two negatives kind of cancel out and make positive. So there we go. Okay. So like I said, 8 times 3 is still 24, but then you look at, okay, 8 times negative 3 is going to make it negative 24. Negative 120 divided by negative 6. What sign is that going to have? I'm in the second row, fourth one, second row. What sign will that have? Thumper. 20. It's a thing now. Yeah, 20, and it's going to be positive because a negative divided by a negative is a positive. Okay, so really just focusing on the signs there. Questions on integers? Okay, very good. Fractions. Multiplying and dividing fractions. Give me the process for how you go about multiplying fractions. What's our rule for this? Sign rules still apply, right? So in negative 13/12 times 3/5, we've got a negative times a positive, so we know our answer will be negative. But how do you go about it? Yeah. Yeah, common denominators, we don't care. Okay, don't need them, don't care. So multiply straight across. So we get 13 times 3 is 39. 12 times 5 is 60. And we have a negative times a positive. So our answer is going to be negative. Of course, we have to simplify. Turns out we can divide each of these by 3. And so your final answer is going to be negative 13 20ths. And it doesn't matter if you put the negative sign, that was poor placement there, but it doesn't matter if you put it up with the 13 only, you put it down with a 20 only, or you put it out in front of the fraction, kind of like I have my first one here. It doesn't make a difference. Okay, any of those values would be correct. Yes? Yeah, if you've got to simplify, you'll do it at some point, whether you do it first before you multiply, whether it's a multi-step thing and you simplify in the middle, or whether you do it at the end, it doesn't make a difference, okay? Just so it gets done. I like to simplify at the very end, just so I don't miss anything, but that's just me. you can simplify at any point. Dividing fractions. Let's take a look at 9/10 and divided by 8/7 here. Methods for dividing fractions. Yes. Sorry? What? Something change, flip. What was the first word? Keep, change, flip. KCF. That makes me hungry for chicken. Yeah, but I know it's KFC. It was close enough. So keep, change, flip. And so you are talking about the flipping method. The keep is the first time I've heard that. So not on the method, but it called that. So I'm working through my head. So the keep is how you know to keep the first fraction the same. I like that. Because in the flipping method, folks often, which fraction do I flip? Is it the first or the second? But keep, change, flip. The first fraction stays it's the same, keep, right? Change refers to the operation. Changes to what? Multiplication. And the flip refers to second. I like that. That's clever. I just always call it the flipping method. Learn something new every day. So 9/10 divided by 8/7 becomes 9/10 times 7/8. And the fact that we've changed from division to multiplication means that we are back to what we did in the first example there, multiplying straight across, right? So we have 9 times 7 is 63, 10 times 8 is 80, and no simplification necessary there, okay? Another method to divide fractions. Okay, so this one would involve not changing the way it's written, keeping it written as 9/10 times, or 9/10 divided by 8/7. Another way to divide fractions would be use cross products. You've heard of that phrase before? Okay, cross product simply means that you are multiplying the 9 by the 7, the numerator of one by the denominator of the other, to again get 63. And then you are multiplying the denominator of one by the numerator of the other, okay, to get 80. So once you kind of understand that, you're not actually going to be dividing 9 by 8 and 10 by 7 there. You are going to be multiplying 9 by 7 and 10 by 8. You can use either method. Yes? Good question. Growing up, when I was not privy to the keep, change, flip acronym, I like that a lot. And we use cross product here. My struggle was always, how do I know which number goes in the numerator, which one goes in the denominator? Okay, and the answer to that is the position of the number in the first fraction is where the product goes. So since 9 is in the numerator of that first fraction, you're multiplying 9 by 7, you know that 63 is going to be in the numerator of your answer. The 10 being in the denominator of that first fraction, 10 times 8, it's going to be in the denominator of that fraction there, which is the advantage to the flipping method here, because it makes it very obvious, because you're just going straight across, right? But either method works. Lucas.
With the question like negative 5/5 divided by negative 7/11.
Sure.
Do we wait until we flip 7/11 until we put the negative sign onto the top one? Or do we put it on 7 then flip?
Well, quite honestly, if I'm looking at negative 5/5 divided by negative 7/11, that third one there, what do I know my quotient's going to be? Since you have a negative divided by a negative, what's your quotient going to be? Positive. So just kind of ignore them, right? Negative 5/5 divided by negative 7/11 will be the same thing as positive 5/5 divided by positive 7/11. So you can kind of just take them out of there first, and then you don't have to deal with them. That's what I would do. Okay. Any other questions on multiplying or dividing fractions? Anyone not named Thumper who has questions on multiplying or dividing fractions? I just did call him Thumper. Okay, your homework is to finish PO4. The integers we did not do, the fractions we did not do. Make sure your answer is written in simplest form, and that is due Monday. Folks, that is how you math.